Okay, talking about our fourth and final conic section, we've covered the circle, which is the one where it is parallel with your, what do I want to say, parallel with the base of the circle. We've got the slanted piece of paper that goes through one of the cones. That's going to give you an ellipse. You've got your paper that goes up and down that is basically kind of perpendicular with that cones, and you get the two parabola looking things. And then we'll get what is called the parabola. Oh wait, we've already talked about one of those. But we're going to take a look at parabola in a little different light. Okay, we're going to talk about a parabola defined as the distance from the focus and the directrix. Okay, so what the focus is this point inside of the curve, just like it would be in foci. This focus just means singular. It's always on the axis of symmetry. This directrix is not really an asymptote, but this line that really isn't part of the graph or actual graph, but part of the characteristic that helps us graph. So in other words, the distance between this foci to the vertice, let's say some distance right there, d, is the same as the distance from the vertice to that directrix. Okay, so that's true at any point that I were to put onto my parabola. Now, we're not actually going to graph with the table an exact version of this parabola. We probably did more exact parabolas in the past, but we're just going to focus on literally the focus, the vertex, and the directrix and how they relate to one another. You can have a parabola either open up or down. That's nothing new to us. No a value this time, but instead of 1 over 4p. If it's positive, it means that it's going to be opening up. And what that p is going to help us out with is it's the distance from the vertex to the focus. If you have a negative 1 over 4p, it opens down, which again makes a lot of sense. Now, if it opens up, remember the focus is always on the inside of the bowl of that parabola. The directrix is on the other side. Now, here's one that's a little bit wild and crazy. It can open to the right or to the left. So I still got that fraction of 1 over 4p. But now the x and the y switch place. I'm going to go back up. Our typical parabola is y is equal to some number and then x squared. And it opens up or down. If we flip it around so it's x equals some number y squared, it either opens to the right or left. And I think that since this fraction here is positive, it opens up to the positive side of the graph, which would be positive side of the x-axis, so that'd be to the right. And because this number is negative here, it's going to open up to the negative side of the x-axis, which would be to the left. Okay, but still, you still have this 1 over 4p. All right, in terms of vertex, for now, we're going to kind of stick those at the origin, 0, 0, just for simplicity's sake. And to find my focus, I'm going to have to take this fraction, 1 over 8, and set it equal to 1 over 4p. And that's regardless if it's going to open up, down, left, or right. Because it's y alone by itself, I know it's going to be up or down. And since this is a positive 1/8, I know it's going to open up. Anyways, back to solving this. I'm going to just basically focus on this denominator part here. And what value of p will make that 4p turn into 8? Well, that p is going to be 2. So if this is my vertex, 2 units up is going to be my focus. So 0, 2. And 2 units down is going to be my directrix. And it's a horizontal line, so it's going to be y equals 2. And my graph of my parabola, for our sake, is just going to be just something like that. I'm not looking for anything too perfect there. I'm looking for your focus, directrix, and your vertex. Okay, might take a little bit of work, but that's okay. We'll add x squared, so we got minus 28y is equal to x squared. Divide by negative 28, y is equal to 1 over negative 28 x to the second. Okay, this one is going to open down. Vertex is at 0, 0. And I'm going to take 1 over 28 and set that equal to 1 over 4p. Now I know it's a negative 28, but I'm going to think of p as 7 because p is the distance. It just tells me that distance. I'm going to go up 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, 6, 7. Okay, since it's opening down, there's my focus. So at 0, negative 7. So a lot has to do with knowing that orientation right there. And my directrix is going to be this line up here. I know I didn't dash the last one, I probably should have. And again, not looking for anything major, but there is my parabola, rough sketch of the parabola. Okay, see how this one is x equals y squared. So now it's either this or this. And because it's negative, it's going to open to the left. Going to compare 1/6 to 1/4p. So p is going to be 6/4 or 3/2. So there's my vertex. 1.5 over here is going to be my focus. 1.5 over here is going to be my directrix. So now my directrix is opening up and opening to the right here. So it's going to open up that way. So x equals 1.5 or 3/2. And my focus is going to be negative 3/2, comma, 0. Okay, so 1/4p, 1/20. So p is 5. So still it's x alone, but now it's going to open to the right. So I've got my vertex right here. There is my focus, and my directrix rather is x is equal to -5 because I got to go 5 in the other direction. And open this up, and if you can tell, my daughter is sitting next to me, attacking me as I record this. And I'm off a little bit here, so that should be at -5. No. It is currently an hour and a half past her bedtime, too. Oh, did it again, but that's going to be that -5. Okay, so if I'm writing my equation, I'm going to go off of my graph here. Since I got my directrix here and my vertex, I got to find out that distance of p. So that is 2 units. So since it's opening up, it's going to be y is equal to 1/4p x squared. So simply enough, put in that value of p. 1/4 times 2. So 1/8 x to the second power. And there's the equation of my parabola. Okay, again, I would suggest, just for the sake of getting to know where everything's at, there's my vertex. My focus here is at 0, -9. If my focus is down here, I mean, that tells me which way it's going to open. It's going to be down. So I know it's y equals a -1/4p x squared. Now it's just going to come down to measuring out the distance of 9. So this particular one, y is equal to 1/4 times 9 x squared. So y equals -1/36 x to the second. Okay, here on the second one here, vertex is at 0, 0. Now here's my focus. Opens to the left, so now it's x equals -1/4, and that value of p, y squared. So that distance is 4. So x equals -1/16 y to the second. Okay. Okay, using that same context with the directrix. So vertex is at 0, 0. My directrix is at -3, so down here. So that tells me it's going to open up, and that distance is 3. So y equals 1/4 times 3 x squared. So y equals 1/12 x squared. Okay, directrix x equals 6. So there's my focus, or my vertex. Here's x equals 6. That distance would be 6, so that p value is 6. So x equals 1 over 4 times 6 y squared, or x equals 1 over 24 y squared. Okay, the course of a sailboat includes a turnaround point marked at a stationary buoy. The sailboat must pass the buoy at a straight line with the shore. The boat flows at a parabolic path. The buoy, which is 40 yards from the shoreline, write an equation that represents it. Okay, so there you go. There's your shoreline. There's the buoy. The thing is the vertex, we'll put that at 0, 0, but that distance of P isn't going to be 40. It's actually going to be half of that, because this distance and this distance are the same. So I put D, but really P. Okay, so since opening up, or I guess we can orient it that way, 1 over 4 times 20 x squared, or y equals 1 over 80 x squared. And there you go. That is parabolas in the not first semester way of looking at them.